right, 8.1 part 3 is just basically word problems that have to do with what we've been doing. It's titled problem solving, technically. But when they say that, they mean word problems. Alright, and so just make sure if you guys are someone doing the retake on Thursday, because no one signed up for it today, you have to have your meaningful corrections done before you do it. So that you have to bring those in as like a ticket to be able to do it. Okay? So if you're not testing tomorrow, I'll get it to you. And I had to cancel the retakes today after school and tomorrow after school because I end up having to go to these meetings. So you have to do it on Thursday during class, and then you're gonna have to watch the video over the weekend of what we do on Thursday. That's fine. All right. So the first thing we're gonna talk about. It's the top of the marker fell off. Thank you. All right. So the first thing we're gonna talk about is compound interest. You guys will see this a lot over the years. You might have already seen it. And we're going to be talking today about interest that is compounded annually, so once per year. So what compounded interest means is like, say you put $100 in a bank account and it had a 5% interest rate, which would be crazy. You should put all your money in that bank account if you find that. So that would mean that at the end of the first year, you would have $105, right? Because they would have given you 5% on top of what you had put in there. So you have $105. Then the next year, they would take your $105 and take 5% of that. And then you have that much at the end of the second year. And then whatever that was, they take 5% of that. So every year, they're taking 5% of like more and more and more and more. So you're getting more interest every year. Yeah? Yeah. Well, usually. Sometimes they're not. Yeah. Okay. All right. All right. We don't need political discussion on my recording. All right. So here's the formula we're going to use. A equals P times 1 plus R to the power of T. P equals the amount invested. And it's P because it's the principal. I'm pretty sure that's principal with the AL at the end. And I was like debating it and I didn't feel like looking it up, so I'm pretty sure it's principal with an AL. That's a 1. Right. Yeah. R is your interest rate. T is the time in years. And A is like the final amount that you have in there. So those are what all 4 variables mean. So I'm going to give you some problems where I'll give you 3 of those values, and you're going to have to solve for the missing one. So we're going to do an example, and you don't have to write down every single word I say out loud. I'll help you figure out what to write down. So the example is, there's someone, and she opened up a new bank account, and she invested $4,000 at interest rate R. We don't know the interest rate. So we know that she invested $4,000, interest rate R. It's always good to like just write down the bullet points, like the important things they tell you in the problem. Yeah, no, you guys are freaking out. What happened to it? There we go. It invested $4,000 at interest rate R, and then I want to know in 2 years, her account was worth $4,410. So after 2 years, she has 4,410. And the question we're wanting to know is, what was the interest rate that got her that amount of money? Alright, so to solve this, we're going to plug in what we know into this equation. So do we know the A? The final amount? What's her final amount? Yeah, 4,410. So we've got 4,410 equals, It's always parentheses 1 plus r. Do we know the r? No, that's what we don't know. It's asking us, like, what is the interest rate? So we don't know the r. Wait, did I do something wrong? Oh, yeah, I forgot the p. Sorry. What was the p, the principal amount? Yeah, 4,000. Sorry. So it should be 4,000, 1 plus r. And then, yeah, we know the t is 2, right? Because it's 2 years. So we can plug in the 2 right there. Yeah, they're really not bad. No, they're really not confusing. You just look at what you know, look at what you're trying to figure out, and see how you can get there. So we're trying to get r by itself. Raise your hand if you have an idea of what we could do to try and get r by itself. What's the first thing we should do? Jack? We could square root it. I think that would work. Here's what I would do. Let's square root maybe in our second step. Since this is the only thing squared, let's go ahead and get rid of this 4,000 first. Let's divide each side by 4,000. That'll get rid of that. So then we're just left with something squared, and we can square root it. You could square root each side first though if you wanted. So let's see. 4410 divided by 4,000 is 1.1025. Yeah, when it's word problems, we can go ahead and do decimals. And then on the other side, we're left with 1 plus r squared, right? 1 plus r, the whole quantity is squared. Yeah, now since the only thing over here on the side with the r is being squared, let's square root that to get rid of that squared. Huh? Oh, like if you factored it out, if you multiplied it out, yeah. And then the square root of 1.1025, you guys will have a calculator to do this, but it is 1.05. And what did I forget? Plus minus. Anytime you take a square root is a plus minus. Well, we still need to do that. We still need to do that. But as soon as you take the square root, you have to put the plus minus. Some of you guys are trying to wait and put it at the very end. You can't do that. Yeah? Well, we are going to end up, I think, using the positive one, but sometimes you could end up using the negative one. Are you listening? So, because if this had been like a minus one over here and we added one, it would make this like bigger. So you still want to include both of them. That's a good question. So yeah, let's subtract 1 to get r by itself. So we have two answers here. We've got positive 1.05 minus 1. What's that? 0.05. And we've got negative 1.05 minus 1. What's that? Negative 2.05. So which of those makes sense for our interest rate? Only one of them makes sense, right? The positive one. So our interest rate is what percent? 5%. Because if we've got 0.05 to change it back to a percent, we move the decimal twice. That would be crazy. 5 is really good. That would be crazy. Put all your money in there. And then beg people for money and put more money in it. You could. Yeah. Yeah. Alright, let's do another one. Alright. So we're going to talk about some equations that talk about free falling objects. This is a physics equation. So the equation we're going to use is S equals 16 S equals 16t squared. And what this tells us is it tells us the approximate distance, and the distance is represented by the letter S. You can. I'm just going to put S up here. It's what people normally use for some reason. So it approximates the approximate distance s in feet as an object freely falls from rest in t seconds. So this is like if you held out like a ball or something and then dropped it, and you said how far did it fall after 1 second, you could plug in a 1 into this and find out how far it fell. Yeah. This is only for Earth. Yes. Only for Earth. Because we're gonna do problems with it. Because this is working your brain out. This is a workout for your brain. You will definitely need to use this. All right. Why not now? All right, so here's our problem. I'll help you figure out what to write. The problem is, okay, at the Grand Canyon, there's a skywalk, like a big bridge thing people can walk out on. At the Grand Canyon, there's a skywalk, and it's 4,000 feet above the Colorado River. I bet 4,000 is important, right? So let's write that down. So it's 4,000 feet above river. So that's what I would write down if I were doing this problem. 4,000 feet above the river. How long will it take a stone to fall into the river if someone drops it off the bridge thing? So how long for stone to hit river? That's what I would write. So we know it's 4,000 feet. We want to know how long is it going to take to hit the river. So do we know the distance it's going to fall, S? Yeah, 4,000 feet, right? So we know our S is 4,000. So instead of S equals 16t squared, we're going to write 4,000 equals 16t squared. And we're just trying to find how long it took. So we're trying to find what t is, how many seconds it took, yeah? You do not have to memorize them. So what do you guys think I should do to each side first to get that t by itself? Yeah, let's divide by 16. You could square root both sides first. It's definitely an option. So t squared equals 4,000 divided by 16 is 250. And then we're going to square root to get rid of the t squared. No. No. 25 times 25 is 625. It is, we'll round to the nearest tenth, so it's 15.8. Do you guys, should I write the positive negative? Can you have negative seconds on Earth? No, we can't really have negative seconds. It's not going to take negative seconds for this thing to fall. So it takes, that's kind of a long time if you think about it. Like 15 seconds? That's long. Yeah, if you jumped off, it'd be 15 seconds of falling before you smacked into the river. Yeah. Okay, I know you guys all want to tell me things. We got to keep going. Guys, we got to keep going. I want to get at least one example on this section 2 done. All right, so that was 8.1. We're done with 8.1. The homework that goes with that is this first one. So now we're starting 8.2. I'll just keep the same one. Think so. All right, so we're going to talk about a new way to solve these problems, and it's called using the quadratic formula. So when we've been solving these quadratic equations, we've learned a few ways already. So let's write down the ways we know so far. So the first way we learned, which was actually like in a couple units back, was to factor it and to get it equal to 0 and factor it. So the first way we learned was factoring. Now the problem with factoring is that sometimes I give you guys problems that you can't factor. So if I give you a problem you can't factor, we learned the thing that we did yesterday. Do you remember what it was called? Completing the square. So first we learned factoring. That does not always work. So then we learned completing the square, which you can always use, but sometimes it's really messy. Like, remember those ones where, like, first you had to divide everything by 9 and you got a weird fraction? So sometimes completing the square is really messy and you might not want to use it. So the third way we're going to learn today is to use the quadratic formula. So remember, this is where we're solving these equations. We're trying to figure out what x is. If we can, we want to factor. Like, factoring is honestly the easiest. Completing the square can be a nice way to do it. And if those don't work, you can always use this formula we're going to learn today, which is the quadratic formula. And the quadratic formula will always, always, always work. No, you guys don't know it yet. This is the general format of a quadratic equation. So we're going to do another day, like maybe at the end of this week, how to get the quadratic formula, like where it comes from. But for now, since we're a little short on time, I'm going to show you what it is, then maybe you guys can help me figure out where it comes from. So here's the quadratic formula. X equals, so like this is going to tell you your answer for x. It's going to equal negative b. So it's like the opposite of whatever your b value is. Whatever that value right next to x is, you put the opposite of it first. And then you put plus or minus the big square root. You're going to have to memorize this formula. On the inside, you take your b value and square it. And then you subtract 4 times a times c. And then that whole thing, we divide it by 2 times your a value. So this is a very, very important formula. We're going to look at on Thursday where it comes from. You have to memorize it. Yeah, I'm going to show you guys a couple songs.